So now that we know how to show two triangles are congruent, what are those 5 ways again? What are the 5 things that I can use to show two triangles congruent? What'd you say? ESA? ASA, angle, side, angle. Yep, that's one of them. SAS, side, angle, side. HL, hypotenuse, leg. SSS, side, side, side. And there's one more. We got 4 of them. Angle, angle, side. Or you could call that one side, angle, angle. It does not matter which order you do the letters in. So now that we know these things can show two triangles are congruent to each other, we are going to do some proofs. So we're adding on to what we were doing the last 2 days. We are going to look at a triangle. We are going to be given information. We're going to mark up the triangles with that given information, just like we did on the homework. And as we mark up the triangle with that given information, we're going to write down what we're doing and why we're allowed to do it. All right, so let's look at our first proof. We have been given that D is the midpoint of segment AC, and that segment AB is congruent to segment CB. So I'm going to come over here. We already know that our first 2 reasons are given. So I'm going to put this information as statements 1 and 2. Typically, I would write this all as just one statement and write given next to it. But because they have this filled in for us already, I'm going to go ahead and write it on 2 lines. So D is the midpoint of AC. I'm going to have to scoot that up a little higher so that I have room for a second line. D is the midpoint of AC. We know that because it was given to us, and we also know that segment AB is congruent to segment CB. Is this piece of information marked on the triangles already? Yes, right here we have some congruence markings. Is there anything on this triangle that I am allowed to mark without it being given to me? BD is congruent to what? BD. BD is congruent to itself. That's this shared side right down the middle. I'm going to mark that with 2 congruence marks. The reason that I am allowed to say that something is congruent to itself is because of the reflexive property. All the reasons that we used before when we were doing proofs, we're going to use again now. If you guys need copies of those reasons to use in proofs papers, I still have one of the red ones and a couple of the green ones over here if you want to come and grab those. All right, so looking at the triangle as it's marked up right here, we just knocked all of those on the floor, honey. Do I have enough marked on the triangle to say that those 2 triangles are congruent? No. Did you have a question? Could we have said that BD bisects? No. We can't say that it bisects because we weren't given that. I know it's going down the middle, but I don't know that it's going precisely down the middle. Now, what I do know is that D right down here is a midpoint. So I could say that BD is bisecting AC, but I don't know that it's bisecting the angle up at the top. I'm not sure about that piece. What do midpoints do? They're going to cut in half and make some things congruent. What are the things that would be congruent because D is the midpoint? AD and DC are congruent to each other. So I'm going to mark those with congruence marks, and I'm going to write down what we just said. AD is congruent to DC. Why would we be allowed to make a statement like that? They said it's the midpoint, and we said that must mean that these two segments are congruent. What are we using there? Midpoint theorem, yes. The midpoint theorem. And now we get to our very last line in the proof. The very last line in the proof, the last statement, should be the thing that we are trying to prove. So triangle ABD is congruent to triangle CBD. And we have to write down why we're allowed to say that. Am I ever, ever, ever allowed to use this as a reason? No. Prove is not a reason. Prove is the action verb of what we are doing in this process. So I can't use prove as a reason. Let's look at the triangle and see if we can find our reason. SSS, yes. When you look at just one of these triangles, we have all three sides marked with congruence marks. So these two triangles are congruent to each other by side, side, side. Nicely done. Let's see if we can do another proof. Let's look down at number 3. Do you guys remember what this style of proof is called? Yep, this is called a flowchart proof. So I know that this piece of information, and these two, when put together, is what I'm going to use to show that these two triangles are congruent to each other. Let's look at where these things are coming from. Segment AB is congruent to segment BC. Where did that idea come from? The given. AB is congruent to BC. We are allowed to say that because it was given. Has that been marked on the triangle? Then we need to go in and mark it up. Segment AB, right here, is congruent to segment BC, right here. Why would we be allowed to say that segment BD is congruent to segment BD? It's congruent to itself. What reason did we use on the last proof when we had something congruent to itself? Reflexive property. Has that been marked on the triangle? No, so we're going to go in and we're going to add that marking. Anytime we make a statement and give a reason, we're going to mark it on our picture too. BD is congruent to BD. Where did this piece come from? The given. Here it says BD is the angle bisector of angle ABC. Here it says BD bisects angle ABC. They wrote the same thing just with less words. So that is part of our given information. We're using that piece of given information to now say that that must mean that angle ABD and CBD are congruent. Let's go find those angles on the picture. Thank you. We're on page 12 in your notes. You're welcome. All right, angle ABD. Well, here's A, up to B, and down to D. So this is one of the angles that's being discussed. That's angle ABD. And then angle CBD. So I start at C, I go up to B, and then down to D. This is the other angle that's being discussed. Why would I be allowed to say that those two angles are congruent to each other? We were just told that BD is bisecting. What are we using to say that those two angles have to be congruent to each other? We are using the definition of an angle bisector. All right, so let's look at the triangle now, or the two triangles, I should say. Let's look at just one of them. It doesn't matter which one you choose. I'm going to look at the right-hand one, though. What do we have marked up on the triangle to be able to say that the triangles are congruent? Yep, side, angle, side. So these two triangles are congruent to each other by side, angle, side. All right, let's flip over to page 13 now. Let's look at proof number 4. We are going to give all the statements and all but one of the reasons. The first reason is given, so what do I need to put in this first box? D is the midpoint of GE. Anything else? Then it says segment FE is, what do these lines right here mean? It means parallel. So we have D is the midpoint of GE. And segment FE is parallel to segment GH. Is there anything in this figure that I'm allowed to mark without being told? What'd you say?
FE and GH.
What about FE and GH?
You're gonna put like 2 R's.
That I was told. Is there anything I'm allowed to mark without being told? We'll get to that piece in a minute.
Oh, okay.
Angle.
And angle H.
We know we can't mark anything about angle H without being told. What are the two things I'm allowed to mark without being told?
Oh, D.
We're allowed to mark
D.
vertical angles, and we're allowed to mark...
FDE and HD.
Well, hold on, I'm just talking like big ideas. What are the two things we're allowed to mark without being told? One is vertical angles, the other is shared sides.
Shared size.
We're allowed to mark shared sides and vertical angles. Do we have either one of those here?
Yeah. Vertical.
Yes, we have vertical angles. So my vertical angles would be this one right here. What would the name of that angle be? FDE. So angle FDE is congruent to, and now I need my other vertical angle. What would the name of this angle be? GDH. Angle GDH. What kind of angles did we say those were? We marked them as congruent, but what type of angle are they? Vertical angles. And so we are using the vertical angles theorem to be able to say that those vertical angles are congruent to each other. All right, let's make use of D is the midpoint of GE. If D is the midpoint of GE, what segments would have to be congruent to each other? Which ones? D is the midpoint of GE, this right here. Which two segments would have to be congruent? Not FH, guys. We're looking at GE, this one right here. We're looking here. That's the one where the midpoint is. ED, this one right here, and DG. Remember, we have to take the line segment that they gave us and split it in half. We can't go looking at a different line segment. No matter what the picture looks like, I know that that other segment looks like it's being cut in half, but that's not what we were told. We were told that it's the midpoint of GE. So I can use this information to say that segment ED is congruent to segment DG. We made this jump because we were told that D is the midpoint, but what are we using then to say those two smaller segments are congruent to each other? What'd you say? We just used it a moment ago. Midpoint theorem, yes. All right, fantastic work so far. Now we've got our parallel lines. We have that FE, this side right here, is parallel to GH, this side right here. So I can come in here and draw what shape? A Z. Remember, when we see parallel lines, we want to draw a Z shape. So I'm going to go on top of my parallel lines, and I want to connect them with a transversal. So like this. Did I draw kind of a Z shape? We're going to connect orange to orange, so this angle up here, and that would correspond to what other orange to orange? DHG, or angle H, right here, yes. I marked angle F as being congruent to angle H. Does anybody remember what type of angle pair I said we find when we draw this Z shape? Alternate interior angles. So we are using the alternate interior angles theorem. All right. Let's look at one of these triangles. Let's look at this one. What do we have marked up in that triangle? Yep, I have an angle right here. I have another angle right here. And I have a side right here. Is that angle, side, angle, or angle, angle, side? That's angle, angle, side. We have to move around the outside of the triangle. I can't like go through the triangle to get to the side. Angle, side, angle would look like this. In angle, side, angle, the side is in between the two marked angles. Yep, so this would be angle, angle, side. So we're going to say that these two triangles are congruent. Here's the statement that I'm trying to prove. Triangle FDE is congruent to triangle HDG by angle, angle, side. Very nicely done. We're going to try to get through the next two. I know we'll at least get through the next one. What goes as my first statement? TB is the, what's that upside down T mean? Perpendicular. Says that TB is the perpendicular bisector of segment RS. And the reason that we are allowed to make that statement is because it was given. Is there anything in the picture that I'm allowed to mark without being told? Yes.
RB.
Not RB. TB. We have a shared side here. I would say that TB is congruent to what? TB. Segment TB is congruent to itself, segment TB. What was the reason that we can use to say something is congruent to itself? Reflexive property. All right. Said that TB is the perpendicular bisector of RS. Let's look at the bisector part. What do bisectors do? They cut things in half. We are cutting RS in half right here at B. So what would be the segments that would be congruent to each other then? RB and BS. Let's write that down as a statement. Segment RB is congruent to segment BS. My reason for that, we were told that TB was a what? Perpendicular bisector. So we are using the definition of a perpendicular bisector. Perpendicular means what? 90-degree angles. Perpendicular means that it makes 90-degree angles. So where TB and RS meet, we are making right angles. So on either side of this, we have right angles. So now I need to write down what I just marked. I said that angle TBR, measurement of angle TBR, is equal to 90 degrees, and the measurement of angle TBS is also 90 degrees. And the reason we're allowed to say that is the same reason we could say this. We were told that TB is a perpendicular bisector. So we are using the definition of perpendicular bisector. All right. So far, so good? I know that if TBR equals 90 degrees and TBS also equals 90 degrees, then the measurement of angle TBR is equal to the measurement of angle TBS. What would I be using to say that? In this equation right here, I took out the 90 and I put TBS in its place. Substitution, or what else could I use? Transitive property. Transitive property or substitution. If the two angle measurements are equal to each other, does that make them congruent? Yes, so angle TBR is congruent to angle TBS. Well, right up above this, we said the measurements are equal. If the measurements are equal, then why can I say that they are congruent? What are we using? Oh, you guys are ahead of me. I'm not looking at the triangles for this. I'm looking right here. Right here we said the measurements were equal, and I'm saying that means they're congruent. If I know the measurements are equal, why can I say that means they are congruent? Definition of congruent angles. All right, we're going to have to add one more line down onto the bottom here. Because now that I know those angles are congruent, I can make my last statement. That triangle RBT is congruent to triangle SBT. All right, so now what you were trying to tell me just a moment ago, we're going to use now. Looking at just one of these triangles, why can we say that these two triangles are congruent to each other? Side, angle, side is absolutely correct. All right, we do not have time for number 6. We will pick up there on Monday. And then we will go over to page 15 and talk about CP-CTC. The homework that you guys picked up on your way in the door is due on Tuesday. This is the last homework of the module. Tuesday will also be the date of the last skills check for this module. So Tuesday, last homework is due. We'll take our last skills check. That's also when you will get the test review for the test next Thursday.